part C, we have now changed gears and we're looking at a rational inequality, but the process is pretty much the same. So we're going to, once again, want to make sure that we have an expression on one side and a zero on the other, and we have that. So we can go ahead and take the interesting x values and put them onto our sign chart. So I'll start off here and I have an x value of 0. So let's come down here and put 0 as a tick mark. Then we have x minus 2 as one of our factors. So positive 2 is going to be one of our tick marks. I'll put that over here. X minus 1 means we're going to have a positive 1. And x plus 1 means that we're going to have a negative 1. So now I want to choose an x value that lives in each one of these regions and determine what's happening with our y's. So, okay, x equals negative 2 lives right there. Now, once again, what I've done is I've just rewritten the expression from the left-hand side, and then what I'm going to think about is the sign of each one of these factors when I plug in that x value of negative 2. So x, well, that's going to be negative then, if we plug in a negative 2. And then if we plug in negative 2 into x minus 2, that's negative 2 minus another 2. That's negative as well. Negative 2 minus 1, going to be negative. Negative 2 plus 1, also going to be negative. Now at this point, I don't really need to worry about the fact that some of these come from the numerator, some of these come from the denominator. We can just count out the fact that I have 4 negatives. And if I have 4 negatives in a problem like this, ultimately what's going to happen is that because that's an even number of negatives, this is going to end up being a positive answer. Now, if I wanted to, I could say that it's a positive numerator and a positive denominator. Positive divided by a positive is positive. That gives me the answer as well. Well, let's keep going. Negative 1 and 0. Well, unfortunately, because negative 1 and 0 are so close, we're going to have to choose an x value that lives between them, and that means it's going to have to be fractional or it's going to have to be decimal. So let's go ahead and do decimal because most people are more comfortable with decimals. So let's choose a negative 0.5 that lives between negative 1 and 0. So if my x value is negative 1/2, my first piece then, x, is going to be negative. Negative 1/2 minus 2 is still going to be negative. Negative 1/2 minus 1, negative. And then negative 1/2 plus 1, now that's the one that's going to change signs here. This time I have 3 negatives, which means that we're going to be having a negative y value there. Between 0 and 1, once again, I'm going to have to go decimal. So let's choose an x value of 0.5 there. 0.5, the x is going to be positive. 1/2 minus 2, that's going to be negative. 1/2 minus 1, going to be negative. And 1/2 plus 1, that's going to be positive. This time I have an even number of negatives, which means my answer is going to be positive. And then let's go ahead and check out something between 1 and 2. Again, they're close enough. I'm going to have to choose an x value that is decimal or fractional that lives there. So let's choose 1.5. If I plug in a 1.5, my x is going to be positive. 1.5 minus 2, that's going to be negative. 1.5 minus 1, that's going to be positive. And 1.5 plus 1, also going to be positive. So I only have 1 negative there, so that means I'm going to have a negative answer. And then finally to the right of 2. Now I have a lot more choices, but again, you don't need to go too wild on that one. So let's choose an x value of 3. If I plug in a 3, each and every one of those factors is going to be positive. And because every factor is going to be positive, that means then that our y value is going to be positive. Now, once I realize that I have all my y values, I'm going to play many of the same games that we did in the previous problem. Because we're interested in the expression on the left being greater than 0 once again means that we're interested in things that are positive. So every time that I see a positive, I want to include that region. Positive, included. Negative, no. Positive, included. Negative, no. Positive, included. Now we have to once again look at each one of these endpoints and ask whether we want to include those endpoints. Because we have a strict inequality here, we are not going to include any of these endpoints. So we're going to have parentheses here, parenthesis, 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 and then we're going to go to the left and to the right forever on each one of those. So let's go ahead and write down our answer in terms of interval notation. So we're going from negative infinity to negative 1. So let's go ahead and write that down here. Negative infinity to negative 1. And because we're not including that negative 1, once again, we're going to go ahead and use a parenthesis there. And because we're going to have a separate piece over here, we've seen that you use the union symbol to say that there are going to be other pieces in other places. So we'll put the union symbol, and we are interested in 0 to 1. Again, notice my use of parentheses there. And then we have another piece, so we're going to have another union symbol, and then we have everything to the right of 2. So we have 2 to infinity. So there's our answer for part C. So now the question is, what would have happened if we had this same problem, but instead of greater than, we had greater than or equal to? So let's put that off to the side as a part D. X times x minus 2 divided by x minus 1 times x plus 1 is greater than or equal to 0. Well, the first comment is almost all the problem is going to be the same. We're still going to have to find the interesting x values and put them on our sign chart. We're going to have to think about the signs for each one of those regions. And then the only thing that's going to change is down here at the bottom. What we now have to decide is which of these endpoints are we going to include. However, when you're looking at a rational inequality, you have to be extra careful about not just coming in and saying, oh, there's an equal to, so we're going to include every single one of those endpoints. Because in fact, we're going to include some of them, but not all of them. We're only interested in things that allow us to have y values that are equal to 0. The other thing that pops up, though, when you're looking at rational inequalities is that sometimes our denominator of the rational expression becomes 0. That doesn't make our y value 0, it makes the y undefined. So what we have to do when we have an equal to on one of these rational inequalities is determine where the function is 0 and include those, but anywhere that we get something that would make the function undefined, we don't include those. So let's go ahead and revisit each one of these endpoints and determine whether it's something that's going to make our function 0 or make our rational expression undefined. So if we look at this negative 1 came from this factor x plus 1 in the denominator. If I plug a negative 1 in there, I'm going to have a 0 in the denominator. If I try to divide by 0, my rational expression is undefined. I still don't want to include negative 1. So I had a parenthesis before, I still want to have a parenthesis there on this greater than or equal to problem as well. Well, let's keep going to the right. Next off then we have the 0. Well, that 0 came from the numerator. We have that factor of x sitting there. So that means we're going to have 0 in the numerator. 0 divided by, ultimately it would be a negative 1 there, we're going to get 0. That's something we do want to include. So I'm going to go ahead and circle this to say I want to include that 0. Well, how about the 1? Well, 1, once again, came from the denominator. So if I plug in that x value of 1, I'm going to have a 0 in the denominator. That makes it undefined. I'm not interested in that. And then finally the 2, that came from the numerator, and we would have a 0 in the numerator. 0 divided by something, we're going to end up getting 0 there, and that's what we want. So yes, we do want to include that too. So how does that then change our answer? I'm going to go ahead and erase part C so that we can write down that answer. So we're going to have negative infinity to negative 1. But we are not going to include that negative 1, so I'm going to go ahead and continue to have that parenthesis. And then we'll have a union. And then I said, I do want to include that 0. So I'll put a square bracket for the 0, but the 1 I don't want to include. So I'll have a parenthesis there. And then, next grouping, we have everything to the right of 2, including that 2. So we have square bracket on the 2, and then we go off to infinity. So there is our answer. So once again, you have to be kind of careful on these problems not to come in and say, oh, if we have an equal to, that means that every single one of these is going to change to a square bracket. Because in fact, that is not the case. If it makes the numerator 0, we'll include it, but if it makes the denominator 0, we won't.